Welcome back to Math Video Tutorials, and thank you for joining in. In this tutorial, I will explain the CAS diagram, and then I will show you how to use it when solving trig equations. For the first quadrant, which is situated between 0 degree and 90 degree, the cos is positive, has positive value. The sine function is positive, and for the tan is also positive. So we can say all the three functions are positive, so we can say all, and we label it capital A. For the second quadrant, between 90 and 180, the cos is negative, the sine is still positive, and the tan is negative. In the second quadrant, the only positive function is the sine, so we give it capital S. For the third quadrant, between 180 and 270, the cos is negative. The sine function is negative now, but the tan is positive. So for the third quadrant, the only positive function is the tan. So we label it with capital T. And for the last quadrant, the cos is positive between 270 and 360. The last quadrant, positive. The sine is negative, and the tan is also negative. So we can say for the fourth quadrant, the only positive function is the cos. So we give it capital C. So let's have a look how to use the CAS diagram when solving trig equation. We've got this simple trig equation, 3 sec theta minus 5 equals 0. We're going to make sec theta the subject by adding 5 to both sides. We get 3 sec theta equal 5, and then we divide both sides by 3 like so. This will allow us to eliminate the 3, and we get sec theta as a subject, 5 over 3. And then we need to rewrite the sec theta using its definition, which is 1 over cos theta. And then we need to flip 1 over cos theta to make cos theta the subject. And we can write 3 over 5 as a decimal number. So to find the size of the angle theta, we're going to say theta is equal inverse cos of 0.6, and we plug this in our calculator, making sure that our calculator is set to 2 degrees. And then to access the inverse function, we need to press shift and then cos, and then 0.6, and then the answer is 53.1. We need to round it, and I'm going to round it to 1 decimal place, so my answer will be 53.1 degrees to 1 decimal place. So theta is roughly equal to 53.1 degrees to 1 decimal place. And the next thing we need to do is to mark our calculated angle in the CAS diagram. So obviously our 53.1 angle will be in the first quadrant. We're gonna draw it here. I'm gonna label it theta 1 and mark it clearly 53.1 degrees. Now, since our cos theta is a positive value, we have 2 solutions within our interval, one in the first quadrant, and the second one will be in the fourth quadrant. This one here is the first one. There will be another one here. We're going to call it theta 2. Now, the angle here is the same as 53.1. but the angle theta 2 will be all this. In order to calculate it, it will be easy. You just subtract 53.1 from 360. So that's 360 minus 53.1, and that will give you 306.9 degrees. Alright, so that is how you calculate the 2 angles using the CAS diagram within our interval. Let's do another example. In our second example, we are keeping the same equation, but change the -5 to +5. We make sec theta the subject, and that will give us sec theta equal -5/3, because you subtract the 5, and then you divide by 3, and you get -5/3. And then you rewrite the sec theta into its regular trig function, that is 1/cos theta equal -5/3. And then you flip each side of the equation to make cos theta the subject. So cos theta is equal -3/5, and that is equivalent to -0.6. Now we can go ahead and calculate the angle theta using the inverse cos of -0.6. And then we grab the calculator to get the answer. So just a reminder, make sure your calculator is set to degrees, because we are working in degrees. And you press shift, cos, and minus 0.6, and the answer is 126.869. We need to round it to a certain degree of accuracy. I'm going to round it to 1 decimal place, so my answer will be 126.9 degrees to 1 decimal place. So angle theta is going to be equal roughly to 126.9 degrees to 1 decimal place. And the angle theta is going to be, of course, this one here. I'm going to call it theta 1. Now, because our cos theta is negative 0.6, according to the cast diagram, we should have two answers, one in the second quadrant and another one in the third quadrant. So the first one is the one we just calculated, is theta 1, and the second one will be this one here, theta 2, in the third quadrant. Alright, so the first one, the theta 1, is 126.9 degrees. And to calculate the second one, you do simply 360 degrees minus the first one, 126.9 degrees, and that gives you 233.1 degrees. Because these two angles here, they're the same. This one here and this one here, the 126.9 degrees. So therefore, to work out this angle, you just do a full turn and then go back or remove or subtract 126.9, and that's what we did in our calculation here to get the value for theta 2. So now we can write down the solution as just angle theta. Usually we start with the smallest value. In this case it is 126.9 degrees, and then comma between all the angles. In this case we have only two angles, 233.1 degrees. And that is the answer to our equation. Alright. In the next example, I will be changing the interval. In this example, I'm going to show you how to solve this equation within this interval. These intervals tell us that we are solving between 0 and 180 degrees. This way. Or between minus 180 and 0 degrees, this way here. Alright, so this one is 0, minus 90 degrees, and minus 180 degrees. So we've got two directions. And to solve this trig equation, we would proceed as normal. You make sec theta the subject by adding 5. So I give you 3 sec theta equal 5, and then you divide both sides by 3 to make sec theta the subject. And then you write it down in terms of the regular trig using the definition. This one is 1/cos theta equal 5/3. And then you flip over this side and you do the same to the right hand side to make cos theta the subject. That's 3/5. which is 0.6. Now our cost function is positive, so we expect, according to the CAS diagram, to have two solutions, one in the first quadrant and the second one in the fourth quadrant. The two angles here are the same size, and to work out the angle theta, use the calculator to get the answer, which is 53.1 degrees. So this angle here is 53.1 degrees. So we have two answers. One of them is 53.1 degrees. The second one is negative 53.1 degrees. So now I'm going to write down my answers together, separated by a comma. Negative 53.1 degrees and 53.1 degrees. Let's do another one within this interval. We have looked at this trig equation in the second example of this video tutorials, but with a different interval. Now we are working within this interval, but let's do the working out very quickly. We obtained sec theta equal minus 5/3 by subtracting 5 first and then dividing by 3. And then we rewrite the sec theta as 1/cos theta using its definition equal minus 5/3. And then we flip it over this equation, the left hand side, and we do the same thing to the right hand side. We get cos theta equal minus 3/5, which is equivalent to minus 0.6. Then we calculate theta by using the inverse cos of negative 0.6. And using the calculator, it will give us the principal value, or the first value, theta, and we rounded it to 126.9 degrees. Now, because our cos function is negative, according to the CAS diagram, we should expect two solutions, one in the second quadrant and another one in the third quadrant. So we would have one here and one here. I'm going to call this one theta 1 and this one theta 2. Our angle theta 1 belongs to this interval, so it follows this direction. So it must be this one, and it is equal to 126.9. 126.9 degrees. Our angle theta 2 belongs to this interval, so it must be this direction. And these two angles are the same, so therefore theta 2 must be negative 126.9 degrees. So to write down my answers, I say theta equal negative 126.9 degrees, comma 126.9 degrees. And that's the answer. And with this exercise, we complete the video tutorial. I hope this tutorial was helpful. Thank you for watching and take care.